and here we have the improper integral of 11 minus 3x over x squared plus 2x minus 3 dx. Let's try to simplify this a bit and put it in a more simple fraction. Here on the denominator we have a quadratic expression. So let's try to put this in. Let's try to factorize this. So we have x squared plus 2x minus 3. So to factorize this, we look for two numbers that we multiply to give us minus 3, and we add them, it gives us 2 plus 2. Of course, the two numbers should be plus 3 and minus 1. So we now have x squared minus x plus 3x minus 3. So we cannot factorize. So here we have x being common. We now have x left here. Then minus, we have removed this x, so we have just 1 left. So we have minus 1. Then plus, what's common between this and this, of course, is just 3. So we now have x left here. We have removed the 3, so we just have 1. So we have minus 1 left there. Now since this is common here, so we factor it out. So I have x minus 1. Then we now have x plus 3. So in place of this, we're going to put this. So we can see we write this integral as integral of 11 minus 3x. 11 minus 3x. Then we have x minus 1. Then x plus 3 dx. Let's clean this a little bit. Alright, so of course we need to use the partial fractions to make this be in a more simpler form. So we have 11 minus 3x over x minus 1 and x plus 3 equal to, so we have a over this one here. So we have x minus 1 plus b over x plus 3 here. So let's multiply both sides by x minus 1, then x plus 3. Let's multiply both sides by this. So if we should multiply this side by this value here, it cancels out. So we now have 11 minus 3x equal to, we have a. Now if we should multiply a over x minus 1 with this denominator here, of course this one cancels out with this one. Now x plus 3 left, x plus 3 left, then plus b, we have x minus 1 left. Now for what value? Now let's try to figure out the values of a and b. Now of course we know that if we should set x equal to 1, this value gets to this value becomes 0, so it will enable us to find what a is. So we now have 1, so we have 11 minus 3 times 1, so we have 8 there equal to, now x plus 1, that means 1 plus 3, x plus 3, that means 1 plus 3, so we have 4 there. So we have 4a, and this a is equal to 2. Then let's figure out what b is from here. So if we should set x equal to minus 3 here, x equal to minus 3, x equal to minus 3, here we have 0 here, so we have 11 minus 3 times minus 3. Now minus 3 times minus 3 is plus 9, so we have 11 plus 9, so we have 11, so we have minus, let's write down 11 minus 3 times minus 3 is equal to, of course this cancels out, so we have b, then minus 3 minus 1. Now this becomes 9 and this becomes 20 equal to, and we have minus 4b here. That means b is equal to minus 5. Minus 5. Alright. Let's clean this a little bit. So we can now rewrite this integral here as integral of a now. So we have 2 over the denominator, which is x minus 1, plus b, which is minus 5, over the denominator there. So I have x plus 3, then the x. The same thing as saying integral of 2 over x minus 1, x minus 1, the x minus 5, then x plus 3, the x. Of course, we can, since this is a constant, we can bring the constant back here, bring the constants back here. So we now have 2, then we have 1 over x minus 1 dx, then minus 5, 1 over x plus 3 dx. Alright. Alright. So here we're gonna let t equal to, let's evaluate this separately, and let's evaluate this separately. Let's evaluate this separately, and let's evaluate this separately. Now, so now we have integral of 1 over x minus 1, then the x. Now we're going to let u equal to this. So we have u equal to x minus 1. So we have du, differentiate that with respect to x. So we have, if you differentiate this, differentiate x, you have 1. Differentiate minus 1, of course this is a constant, so you just have 0. Then that means dx is equal to du. So here we'll now have integral of 1 over u now, because everything here is u. Then dx is equal to du. Of course, the integral of 1 over u is natural logarithm of the absolute value of u. Then we need to put in a plus c here. Well, let's forget about that now. And then after the integral, we'll put it in the plus c. Then same thing here. Let's evaluate this integral. So let's evaluate this integral. So we have integral of 1 over x plus 3 dx. Same thing here. We set in this time. Let's use t equal to x plus 3. That means the t over dx is equal to, differentiate the x, you have 1, differentiate plus 3, you have just 0. So you have dt is equal to dx. Therefore we can say this is integral of 1 over t. Everything is t. You have the, of course dx is the same thing as dt, so we now have dt. I mean, this is same thing as the integral of absolute value. This integral is equal to the natural log of the absolute value of t. Then sorry. Okay, so we can now rewrite. So here we have 2 times this integral here. Now this integral here is ln u, or natural logarithm of u. Ln u, and what is u? Of course, u is x minus 1, so we have x minus 1, x minus 1, then minus 5 times this integral here, which is natural logarithm of t, absolute value of t. Then you have natural logarithm of absolute value of t. And what is t? Of course, t is x plus 3. You have x plus 3. Then we can now put a plus c. Yeah, and that's it. And let's simplify this a bit using logarithm properties. Before we put in that c, let's simplify it first. Let's clean this up a bit. Let me write this here. So we have 2 ln x. First, of course, from basic knowledge of logarithm, you know that if you have logarithm a, then we have b base c. Same thing as saying logarithm base c, then b to the power of a. So your 2 here is your a. Then you have logarithm. Then we have c here. Of course, the base here is e, the Euler's number. So this value x minus 1 is the b. So we can now rewrite this as ln of x minus 1 raised to power 2 minus ln of the absolute value of x plus 3 raised to power 5. Then let's put in the plus c. So of course, from the logarithmic property, if you have logarithm b base a minus logarithm c base a, same thing as saying logarithm, since they have the same base, you have a, then you divide b. Since you have minus a, say b divided by c, b divided by c. So we do it the same here. So we have logarithm to the base e. We have absolute value of course, so we now have this divided by this. So we have x minus 1 squared over x plus 3 raised to the power 5. Then we now have plus c, and that is the solution to this integral.